So, our second part of this video is about permutation and combinations. Now, these are two types of, I guess you would say, possibilities that could come out of it, in which, for permutation, the order of how a possibility will be determined matters. So, order matters in permutation. Order? Good. In combination, it doesn't really matter. So, no order matters. I spelled order wrong. But in combinations, order does not matter. So that's basically what they both mean. Permutations, when order matters in a word problem or in a to find possibilities. And combination is when order does not matter. So the equations for this, equations would be P for permutation, and the number of possibilities out of total. Let's say total outcomes. There, I am going to say total outcomes. So A is the possibilities, and B is the total outcomes. Whereas C is the same thing, you have A and B, but the setup is different. So you would have to do, I forgot the factorial, there you go. So you would put your total possibilities on top, so it would be A factorial. And factorial means like it goes let's say you had like 1 factorial, one factorial. That means, oh, that's a horrible example, sorry. Say you had like 10 factorial. But that means that's basically same thing as going 10, 9, 8, 7, all the way down to 1. You get me? So you're multiplying. So it just means it's just squished up, so you know, like it just goes down. You're multiplying everything to 1. And so to continue, if I can get my thing. So you have the total possibilities on top. Then in parentheses on the bottom, you have your total possibilities minus your total outcomes. And that's it for factorial. And once you get that, you just solve it out. And for C, it's kind of different because then you have your total possibilities on top. You have the same thing, but instead you have your total outcomes again on the opposite side. Not on the opposite side, next to the parentheses. So basically what the formula is, so let's give you an example of permutation, shall we? So, an example of permutation would be, say it's your birthday and your mom decided that, hey, I'm going to get you a clown that I met at downtown. He looks sanitary, he's not total drunk, but, he's decent enough. We'll call him Bobo the Clown. Because, Bobo is not like a serial killer name or anything. I hate clowns. Anyway, say Bobo the Clown comes to your party. He is really cheap, so he only has 10 balloons. Okay? And say at your party there are 6 kids, including yourself. So there's 6 kids in total, including yourself. And we want to know how many ways can the clown give each child a balloon. Now, to decipher what permutation and combination is, we have to listen to what the question says. It asks how many ways can the clown give a child a balloon. So say we have our 6 kids, 1, 2, 3, 4, 5, 6, and say we have 8 balloons. They're all the different colors. So say we have a red balloon. Let's say we have a yellow balloon. Can't really see it, a yellow balloon. Say we have a pink balloon. Let's say we have a pink balloon. We have a brown balloon. We have a dark purple balloon. So that's 1, 2, 3, 4, 5. Say we have a weird color white balloon. Oh, you can't even see it. Let me redo that one because you can't even see it. Sorry about that. Say you have a gray balloon instead of that color. So you have 2, 4, 6. 2, 4, 6. Say you have a this color balloon. This color. That looks almost exactly the same. An orange balloon. Let's go with that. So you have 2, 4, 6. 2, 4, 2, 4, 6, 8, 9. We need one more. Ugh. Done. I hate counting. And a black balloon, just like your black soul. Say we give each child, say we give this child, let's say, the red balloon first. We give this child the yellow balloon. Give this child the pink balloon. We give this child the brown balloon. We give this child, we give this child a black balloon. And we give this child this blue balloon. So in total we've given out 6 balloons, and we have 6, 7, 8, 9, 10. We have 4 balloons left. Just pretend they're different colors. I don't feel like going through the colors again. Okay, so say you give each child those balloons in that certain order. Listen to what I said. You give each child those balloons in a certain order. Now, it's asking how many ways can the clown give these balloons. So that's one way he can give it. Another way he can give it, instead of giving the first child the red balloon, he could have given the child the yellow balloon. The first child the yellow balloon first. And then the second child the red balloon. Then the third child the brown balloon. The fourth child the pink balloon. The fifth child, sorry, I lost my count, the blue balloon. And the 6th child, the black balloon. That's the second way. You see, reading the question carefully and understanding that one is order and one does not contain order is a key thing to figure out if it's permutation or combination. So a simpler way of making it, to simplify it a little more, so I won't confuse you because I think I just did. If it's asking for a way or a certain order, because that's like one of the key words, order, it's asking for permutation. If it's asking maybe how many different, this is when it gets hard, because how many different, let's say, nope, how many different ways, or like, how many different kinds, let's go with that, of like, how many different kinds of, it's hard to explain. But for permutation, just focus if it's in order, and for combinations, if it asks if there's a certain, how many maybe different ways you can put a pizza together with only 2 toppings and 3 vegetable toppings, and you have the choices from 6 meat toppings and 9 vegetable toppings. That's like how many different kinds. So then those different kinds, they don't need a necessary order. It's asking for a different type. It's kind of confusing, but hopefully when I show you this example, it'll make it easier. So it's